Here we have a different example of a rational expression. The ones that we've been dealing with had both quadratic trinomials as the numerator and denominator. The top was a quadratic trinomial, so was the bottom. Here, I don't have a quadratic trinomial in either place. I have a linear binomial and I have a cubic binomial. We will still start this problem by factoring. If something is linear, unless you have a greatest common factor, you probably have nothing to factor, because usually a factor, one factor, is linear, usually, okay? So x minus 2, you're good. I'm going to put parentheses around it just so I remember it's done. On my denominator, however, that's the difference of two cubes. That was factoring method 3 from the beginning of the year. On the comment section or description underneath the video, I will put the link to that lesson. But I don't think everyone's going to watch the lesson. You might just need to be refreshed. There'll be examples there too. I did one with you guys like a week ago, and it was part of the homework. I recorded it and I shared that with you as well. We did x cubed minus 27. So here we use our x-ray vision. We're like, what's being cubed? I put on my cubing glasses. What's being cubed to make x cubed? Easy peasy, x. What's being cubed to make 8? You guys have to have your cubes memorized. We did it in September. Most of you forgot them. 2, right. 2 cubed is 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, if you don't know them, you're jotting them down on the side of your page. 6 cubed, 216, 7 cubed, 343, 8 cubed, 512, 9 cubed, 729, 10 cubed, 1000, and I can go to 11. 11 cubed is 1221. So, and 1 cubed is 1, 0 cubed is 0. So this is a 2. Then we make our parentheses. 1 is little, 1 is bigger. So 2 terms, linear binomial. 3 terms, quadratic trinomial. We take the 3's, we put them in our pocket. X minus 2 goes here. Save those 3's. Now we're sprinkling the 3's as our fairy dust. What's x times x? X squared. X times 2, 2x. 2 times 2 is 4. I did not put signs here. Then we use soap to clean up our fairy dust. Same as what? The original problem. Opposite, so it's plus. Opposite of that, always plus. It's just plus. Next step. Do you have any common factors in your numerator and denominator? You bet your sweet butt you do. The common factor you have in your numerator and denominator is the x minus 2. If I cross out x minus 2 from my numerator and denominator, what is left in your numerator? Not a 0, but a 1. That's it. We should also remember that this quadratic in a cubic, a sum and difference of cubes, when we factor to get the linear and quadratic, the quadratic doesn't factor. You should also know from a recent lesson that when we solve this type of problem, when we solve this, you should remember, we did very specific examples like this, and I went over this with you, that the quadratic, when you try to solve, you have to use quadratic formula because it's not factorable. And when we did that, I promise that we did and always will, in the quadratic of a sum or difference of cubes, listen to what I'm saying, the quadratic in the sum or difference of cubes will always give you imaginary answers when you're solving, not real. So do we need restrictions from that? No, nothing. It doesn't give us any restrictions because nothing will make it equal 0. There's only imaginary answers, no real ones. So we don't get restrictions from that, okay? So imaginary solutions, I promise, if you forget, I'm going to share that lesson as well underneath where we were solving x cubed plus 27. That'll be linked underneath. Imaginary solutions, therefore, 3 dots in a triangle means therefore, no restrictions from that part. And then also I'm going to write not factorable. All right, just because something is not factorable though, okay, does not mean there's no restrictions. They're not synonymous. They don't go together. We'll talk more about that later. But this right here does give us restrictions. So this is our simplified answer. I only have one restriction. Can anyone tell me what x cannot equal? X cannot equal. This should be amazing.
+2.
positive 2. Correct. Perfect. Thank you. X cannot equal positive 2. So the simplified answer is this right over here. And the restrictions, I just want to grab a different color highlighter to indicate it. The restrictions, there's really just one. X cannot equal, it's positive 2, and that's the end of this example. What you will have to do, so your homework, if you don't want to copy it now, that you're going to do on your own, you're going to get from the end of this video, which I will upload. If you don't see it uploaded by the end of the day, the school day, just pop in to office hour and we'll get that squared away, but I'm going to try to do that right now. So we are going to do the following example. If you have a question, go ahead and shout it out while I write these down for you.
Can I resubmit my corrections?
You're going to put your corrections on another post anyway, so I'm going to put that with your classwork for today. So same directions. You're going to simplify and state restrictions. Simplify and state restrictions. That's a big dot on that eye. Simplify and state restrictions. So number 1, x squared plus 10x plus 25 will be my numerator. And number 2, oh, duh, that's my numerator. How about a denominator? Hello. X squared plus 9x plus 20. That's the first one. And next, 2x squared minus 3x minus 2 over x squared minus 5x plus 6. That's the second one. And let's do one more. I could do one that, all right, in this one, I'm going to add a detail to it. I'm going to include something like this and turn it around a bit. So let's do x cubed plus 125. And I'm going to put divided by. Remember, division by a fraction, you can bust out some keep, change, flip. All right? X squared minus 5x plus 10. Sorry, that's so squashed. Then let's do x plus 5. And let's do x minus 5. So your hint, can't read that, I just said it, rewind it and listen. You're simplifying all three and stating restrictions. But this one, you will have to do the rules we did earlier when you are at, maybe today or not today, where you keep, change to multiplication, flip. And the restriction, big hint, restrictions come from factors that are in a denominator, whether they're in the denominator in the original or anywhere along the process. Keep that in mind. All right, so be careful, simplify, state restrictions. I'll put a post up for these to be turned in. And if you understood this example and you got it right, thumbs up. No, thumbs down. The examples from today will help you with the assignment. Have a great day.